To try to understand how things changed with human settlement and the introduction of sheep to Iceland, we can use a simple representation using state and transition models. State and transition models were proposed in the late 1980s by Mark Westoby and collaborators. These models have been applied to rangelands worldwide to identify research needs and guide management efforts. The basic idea here is that different ecosystem states can coexist in a landscape. Each of these ecosystem states is maintained by its own internal feedback processes. In essence, these models are diagrams consisting of boxes and arrows. Each box represents a different state in which an ecosystem can occur. The arrows linking the different boxes represent transitions between the different ecosystem states. Ecosystem states are broadly characterized by the structure and composition of their vegetation. For example, we could think of forests or grasslands as different ecosystem states that can coexist in a landscape. Different drivers can cause shifts from one ecosystem state to another. For example, a forest can turn into a grassland through wood cutting. Some transitions are reversible, meaning that if we remove the pressure driving the shift, the original state would be reverted. In this case, if we stop wood cutting, we may have natural regeneration of the forest. However, transitions can also be reversible when the system does not recover after removing the pressure. In our system, we may have eliminated all the trees in the surroundings through wood cutting, so there are no seed sources available to recover the forest. As well, grazing by livestock can prevent the regeneration of tree seedlings, so the forest does not recover. We say then that the system has crossed an ecological threshold. By understanding and identifying these transitions and thresholds, state and transition models can guide management efforts and research. If we think of Iceland before the influence of humans and large herbivores, we can imagine a few possible ecosystem states. On the one hand, we had the original birch woodlands. In areas that were unsuitable for tree growth, heathlands and grasslands would have developed. Heathlands are areas dominated by small shrubs, and grasslands are dominated by grass-like plants. Wetlands, partly inundated or very moist areas, would have occurred in lower elevation areas and depressions. As well, some moss or lichen-dominated areas may have occurred, as early colonizers of young substrates, like lava fields. And of course, we would also have naturally occurring deserts, the barren areas. During this time, transitions between the different ecosystem states would have been relatively slow, and mainly driven by changes in climate, or periodic events like volcanic eruptions or glacial outbursts. For example, from the paleoenvironmental record, we know that the extent of woodlands in Iceland during the Holocene tracked fluctuations in climate. Birch forests were most dominant in warmer periods, while they retreated to lower elevations during colder times. It has been estimated that, at the time of settlement, birch woodlands covered somewhere between 8 to 40% of the country, with the most recent estimate of 24%. Then humans arrived, and so did sheep. Let's stop here for now. In the next sections, we will see how the likelihood of the transitions between these states have changed with human influence, and even how new states have emerged. But the key point here is that we can use relatively simple models to represent ecosystem dynamics and to structure our knowledge. These models provide a framework to guide research efforts. For example, if we realize that we know very little about what drives a specific transition, then we can design an experiment to test our ideas. We will see an example of this later on. State and transition models can also help focus management efforts if we understand better the ecological processes behind those transitions.